Hi, so today's video is going to be a review of the laws of exponents and scientific notation. Now remember, these videos are a review, so I'm really not going into the why, I'm going into the how. If you want a video on the why, then you can see the full video on the laws of exponents. But for today, let's review some things that you've learned in Algebra 1 and possibly even in Algebra 2, depending on what class you're in. If you are multiplying powers, like this, and the bases, this is the base, and that's called the exponent. The bases are the same, as long as they're the same, and they have to be the same thing, then you can, when you're multiplying, you can add the exponents. So this would become x to the 2 plus 5, which is 2 to the 7. Okay, now that can get slightly confusing if I do something, say, like this. I say x squared and I use parentheses, okay? That's still multiplication and it would still be x to the 7. All right, but then I can take a exponent, a power or a base raised to a power, and then raise it to another power. I like to call this power times a power. And this is a different situation. We don't add the exponents, we actually multiply the exponents. So this would be x to the 10. If you take my class, then sometimes you'll hear me say, I call this power times a power, and I say power times a power, add them high. Power to a power, multiply. So just one way to think about it. All right, so you've also learned how to divide exponents. Now, one little technique I use is that when I'm dividing exponents, I always bring the smaller exponent to the larger exponent, and I subtract the numbers. Never change their sign, I just subtract them. So in the top here, I'm going to actually put a placeholder 1. I'm going to bring that exponent of 2 down to the 5 and subtract them. And that's going to give me 1 all over x cubed. All right, same works over here. I'm going to bring the smaller exponent to the larger and subtract. And that's going to give me x to the 6 minus 2, so x to the 4. Those are some basic rules of exponents. A couple things that you kind of have learned at some point and you just need to remember is that anything raised to the 0 power is the number 1. Any number, any variable raised to the 0 power is the number 1. All right, now let's just quickly review negative exponents. Now, negative exponents, like in this case, if I want to make that exponent positive, then I take whatever it's attached to. It's actually not attached to the 2 because there's no parentheses. And I bring it down in my fraction and make it, I'm sorry, made a mistake there. I bring it down in my fraction and it becomes 2 all over x to the 5. The same is true if I gave you 2 all over x to the negative 5. If I want to make it positive, I have to bring that part up and make it positive. So that would become 2x to the 5. All right, so those are just the basic laws of exponents. There's some other rules that apply and some cool tricks and cool patterns that occur, but those are what you've learned previously. So let's just review scientific notation. So scientific notation is really a way to express, we want to express a very large or a small number without having to write all the zeros, okay? So it's a way to express either a very large, a very large number or a very small number using exponents. There's a couple things you got to know though. Scientific notation is normally written in the form c times 10, I'll say to the n power. So it's a number times 10 to the n power. Now, there's a couple things. There's a restriction on c. c has to be greater than or equal to 1, and it has to be less than 10. So you always have to think about that. So here's what I mean by that. 9.2 times 10 to the 3, well, that's good scientific notation. Why? Well, because 9 is between 1 and 10. What would not be good would be 156 times 10 to the 3, because that c is greater than 1. So I'd have to show you a way to actually simplify that. All right, well, let's talk about how you work with scientific notation. To rewrite scientific notation from decimal form, so if I wanted to write it in decimal form or standard form, that 10 to the 4 is actually being multiplied to the 1.34. And basically all you have to do is move to the right the same amount of decimal places as the exponent. So I have 1.34. I'm going to move 1, 2, and then I'm going to have to add 2 zeros. So my number would be 13,400. Okay, 7.3, 10 to the negative 5. When the exponent's negative, instead of moving to the right to make it bigger, you're going to move to the left to make it smaller, 5 places. So 7.3, I'm going to move it 1, 2, 3, 4, and 5. I'm going to replace those 4 spots with decimals, and so my answer is 0.000073. So that's how you go from decimal form from standard form into a decimal. All right, what about if we want to rewrite something in scientific notation? So if the original number was bigger, okay, then your exponent will be positive. And if it's smaller, your exponent's going to be negative. All right, so first what I do is I look at the number that I have, and I have to meet my restriction. So I need it to be the number to be between 1 and 10. So I'm going to put the decimal right here. So that's going to give me 2.5675. All right, then I count the decimal places and the zeros that I have. And so I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So to the right of the decimal, I have 9 places, so that would be 10 to the 9 power. All right, same thing with if it's a decimal and not a big number, we want to make it smaller. I just know that means my exponent's going to be negative. So I write my C, which would be 7.65 times, so I put my decimal there, and I've got how many decimal places would I need to move? 1, 2, 3, 4. So that would be times 10 to the negative 4. All right, so that's how you work within scientific notation. Now, operations on scientific notation, you got to be really careful because it looks trickier than it is. So for example, 1.4 times 10 to the 3 and then 7 times 7.6 times 10 to the 4. This is not a place we use the distributive property because there's no addition or subtraction. This is actually multiplication. So what this actually means is 1.4 times 10.3 times 7.6 times 10.4. So we want to we want to multiply the things that are easier to multiply. So in this case, I'm going to multiply the 1.4 and the 7.6. That's going to give me 10.64. Then I'm going to multiply the 10 to the 3 times the 10 to the 4. I'm going to use the laws of exponents, power times a power, add them high, and that gives me 10 to the 7. All right, so now I've completed the multiplication, but now I've got to make sure that this meets the restriction. It doesn't. So I have to move the decimal 1 place this way. So that becomes 1.064. Now, but by doing that, I actually have to change this exponent. I have to make it 1 bigger because I need that 1 more decimal place to move. So that would be times 10 to the 8 power. Now, I know I'm going really fast because I'm just kind of giving you a review. Please feel free to rewatch this if you need to and practice the examples that come with it. All right. Let's try dividing. Now, this one just gave me the division symbol. I'm actually going to show you this one by writing it using the fraction bar as the division symbol. Okay, so much like we just did, we can simplify by dividing these numbers. So 1.2 divided by 4.8 is 1/4. Okay, now I'm actually going to write that as a decimal. So 0.25 times. I'm going to bring the smaller to the larger and subtract. That's going to give me 10 to the negative 1 minus negative 4. So I'm bring the smaller to the larger and subtract. So that becomes plus 4. So I get 0.25 times 10 to the 3 power. Then I check my restricted value, and this is too small. So I'm going to make it 2.5. But because I'm moving back 1 decimal place, I actually need to reduce this 1. So that would become 10 to the 2 power. All right, guys, so that's a review of laws of exponents and scientific notation. Have a great day.